Hello, and welcome to Advanced Mathematics 1, Unit 1, Part 2, which is on the definition of a function and functional notation. So let's jump in. By the end of this lesson, you will be able to do the following things. You'll be able to determine if a relation is a function. You'll be able to find the domain and range of the relation, determine if a function is a one-to-one function, and use functional notation to evaluate functions. All right, our main concept is as follows. A relation is a rule that maps a set of input values, which is called the domain or the x values, to a set of output values, which is called the range or the y values. So in other words, it's just a rule that changes one thing into something else. It could be the same thing, but it's a rule that allows you to take a set of numbers and change them into a different set of numbers. A function is a very special type of relation where every input value maps to exactly one output value. So in other words, if you put in a value for x, like 2, you're only going to get one y value out. So 2 isn't going to go to both a 3 and a 4. It's just going to go to a 3, or it's just going to go to a 4, or etc. And then a one-to-one function is a very special type of function where each output also comes from unique input. So in other words, the y value only comes from one x value. So if y is 3, it's only going to come from one value, like 2. So it's not going to come from more than one x. All right, let's jump into our examples. In these examples, we're supposed to determine the domain and the range of the relation. We're supposed to tell if the relation is a function, and if it is a function, we're supposed to tell if it's one-to-one. So if it's not a function, we don't need to worry about one-to-one. So let's jump in. When we have ordered pairs, it's easiest to start with the domain because that's going to help us determine if it's a function. So we're going to list our domain, excuse me, by listing all the x values from their smallest to their largest values. So we're going to put that in a set notation. Sorry for the very sloppy set. We're going to start with the lowest value, which these already are in order from lowest to biggest. So -2, -1, 0, 1, and 2. Now, as I went through that, I noticed that each one of those was only there once. So that means each x value was only paired with one y value, which means that this thing is a function. And then I will go ahead and do my range next, which is the set of all y values. And so I'm going to look at my y values from smallest to biggest. The smallest y is 0, which you can already see is there more than once. And then I also have 2, which is there a bunch of times. So that means this thing is not one-to-one because each of those y values came from more than one x value. 0 came from both 1 and 2. 2 came from 3 different things. If it was just one of them, it would be fine. It's still not one-to-one if any y value is paired with more than one x value. All right, let's do the same thing with part B. So we're going to start with our domain, which is our x values. Our smallest x value is 4, which is there twice. Second smallest is 5, then 6, then 8. Because that 4 was there twice, we can see it's paired with both a 0 and a 3. Therefore, this thing is not a function. All right, so now we go back to get the range. So that's our set of y values. So it looks like our smallest y value is 0. Then we have 2 over here, then 3, then 4, and last but not least, 7. So since it's not a function, I don't need to tell if it's a one-to-one function because it's not a function. So there we go. All right, example 2, we have a function that is depicted as a function map. This little diagram is called a function map. These are very, very easy to do domain and range, so I'm going to start with that because the domain is just the input values and the range is the output values. So domain, I'm just going to copy them from that first diagram over here, which is 0, 1, 2, and 3. I'm going to do my range. That's going to be the output values, which is over here. That's -3, 0, 1, 2, 3. It was almost in order, but just not quite at that back part. All right, so now I want to tell if it's a function. So I'm looking at the x values and seeing if any one goes to more than one thing. And you can see here this 2 goes to both a 3 and a 2. So therefore, it is not a function. So again, I don't have to tell if it's one-to-one, but if it was a function, I would do the opposite. I would look at the y values and see if any of them came from more than one x. So that is our second example. All right, before we move on to more examples, we need to introduce a couple new concepts. So first of all, we have what's called a vertical line test. This is a way of telling if a function that is graphed on the Cartesian coordinate system is a function. And you tell by it, it says a relation is a function if any vertical line drawn only crosses the graph once. So that means no matter where you draw a vertical line, it can only cross once. If it crosses more than once anywhere, then it's not a function. And then we can tell if a function is one-to-one with the horizontal line test. So we can draw horizontal lines across, and a function is one-to-one if any horizontal line only crosses once. So if there's any time where a horizontal line crossed more than once, then it would not be one-to-one. All right, so in examples 3 and 4, we have two graphed functions on the Cartesian coordinates. Example 3 is a bunch of plotted individual points, which we handle a little differently than we handle a smooth graph like example 4. The smooth graphs are the most complicated when it comes to telling the domain and range. But first we'll start with example 3, which is a bunch of points. And we'll just start with our domain and range first again. In this case, we'll go ahead and we'll just list the x values from smallest to largest. So the smallest x value is 1, then 2, then 4, then 6. We'll do our range values, which is our y values. So we start at the bottom and work our way to the top. So the bottommost y value is 0. The next one is 1. Then we have 2. Then we have 5. Now we want to tell if this thing's a function. So we do the vertical line test. If we draw a vertical line and it crosses more than once, which this one does, crosses both here and here, then this thing is not a function. All right, so that's example 3. Obviously, if it was a function, we would do the horizontal line test, which this would also fail. But we don't need to do that because it's already not a function. All right, example 4 is a smooth graph. So I'm actually going to start by determining if it's a function or not. So I'm going to draw my vertical lines through the graph. And I can see if I draw them basically anywhere, they're only going to cross the graph one time. So this thing is a function. Then we're going to do our horizontal line test to see if any horizontal line would cross more than once. And yeah, you can see obviously that a horizontal line crosses more than once. So it is not one-to-one. Now this is where things get just a slightly more complicated, just because it's probably something you've never done before, which is writing things in set notation and explaining domain and range in terms of a graph. So for domain, we're looking at the set of x values. So we're looking left and right on the graph, and we're looking for a definite start or end point on the left or the right. But as you can see, this graph just keeps going, keeps going, keeps going, and keeps going, and keeps going, and keeps going. It means this thing never ends on the left and never ends on the right. So that means the domain is all real numbers. Now you can write that in a couple ways. You can just write all reals. Or you can write the symbol for all real numbers, which is a funny looking R with an extra bar on the end. All right, and now we'll do our range. And our range is our set of y values. So we're looking at top and bottom, and we're looking for a definite start or end spot. So this thing starts here and then keeps going higher and higher and higher forever. So it starts at 0 and goes up. It includes 0 because there's a point there. So basically, the range is all y values that are bigger than or equal to 0. So how we write that is in set notation. We start with a set, and we say the set of all y's that are members of the reals. That's what this, are elements of the reals, sorry. It should be like a funky looking E. And then you write a bar, which means such that. So this is set notation. So this says y is an element of the reals, such that. Now we want y to be greater than or equal to 0, so we write y greater than or equal to 0, and then we end our set notation. So that's probably going to take you some practice. Just take your time, think it through. You're really just looking for the left and right, and then trying to write it in this format. So that's all there is for that one. All right, we're moving on to our last concept, which is on functional notation, which is just a different way of writing an equation like y equals something. Instead of writing y equals something, we write it as a function. It can be any letter, and it's read f of x is how this is written. So it's the function f of x, because I'm putting x in as my domain. And what f of x does is it takes 5 and it multiplies by x squared. So no matter what the x is, I'm going to square it and then multiply by 5, and that's going to give me my y value, which is considered f of x, or the function. Now, these problems are going to ask you to evaluate the function at a particular point. So it's saying evaluate f of 2. So in other words, it's asking you to put 2 where the x is each time. So this would be 5 times 2 squared. 2 squared is 4, times 5 is 20. So that's how you would evaluate f of 2. All right, we'll go to our example next. All right, our example has 2 parts, an A and a B. The biggest problem people have is putting in the number correctly for the letter. So the way to really help yourself with that is to put parentheses everywhere you see an x. So I'm evaluating h of x equals 18x minus 0.5x. So what I'm going to do is I'm going to replace the x with a parentheses. I'm going to put the parentheses here. And then I'm going to plop the value that I'm evaluating into that parentheses. And therefore, I'm putting that -2 in place of that x. Now I can go ahead and do the math. So I do multiplication first. So -0.5 times -2 is a half of 2, which is 1. And it's positive because negative times negative is positive. And then I finish by adding my 18 and my 1, and I get 19 as my final answer. All right, in part B, we have a little bit more here. You can see we already have parentheses, so when we do that, I generally replace the parentheses with brackets so that I can put parentheses everywhere else. So I have x times the quantity x squared minus 3x. So x times the quantity x squared minus 3x. You can see I'm putting parentheses everywhere there's x. Then I'm going to put this -4 in all of those parentheses. because I'm replacing the x with -4. So now I'm going to start with my symbol of inclusion here. I'm going to start with my multiplication. I can also do my exponent at the same time. So -4 squared is -4 times -4, which is 16. And then we have -3 times 4, which is 12. So that's what's inside there. So I'm just still have that thing on the outside. So 16 minus 12 is 4. And I still have this -4 on the outside. So I end with multiplying -4 times 4, which is -16. And that is all. So that is our lesson for today. So I will see you next time.